it's been a few days, so I thought I'd give some updates. This video is part 2 on a build log of building a robotic tentacle. So the TPU print finished, and it's turned out really nice actually. The geometry worked out, it can curl up into a spiral very nicely, like that. And now we'll just run some strings through it and just see how it can control. Well, now that the knots are done, it's time to test it out. Okay, that looks like a nice spiral. This is honestly harder to pull than I thought. It'll always try to curl up like below the base point. So when I designed the base, I put a little slant over here so that it would like curl up and run against this. So let's just connect it all up. I'm gonna run the strings through. And then it slides on nicely. Oh, look at that, now it makes a nice grabbing motion. Let's test it on this nunchuck. Wii nunchuck. You know, it's too hard to actuate by hand, so let's get some motors working. Okay, now I have installed all the necessary software. So hopefully I should be able to just like enable this and enable that. And if I set the voltage, the motor should start running. Oh, look at that. Oh my god. Let's go. I was also wondering if it could like detect like current spikes. So you could look at that like this is the current. And if I like grab the motor to apply some resistance, you can see it like definitely spikes up very noticeably. So hopefully I'll be able to use that to detect contact. Right now this is Phoenix Tuner and I'm running a bunch of FOC software like Driver Station. Now let's connect everything together and test it out. So I designed these pulleys that slide on the motor nicely, and they have this little hole at the top, so I could just put the string through. Then afterwards I could just basically put a set screw like this, and then it'll just hold the string in place. And then I have this case and some screws to hold it all down. Okay, perfect. Let's test this out now. And let's just try it as slow as I can first. Okay, that was surprisingly quick. I just e-stopped it. So replaying that footage, good news is that when this like crawled up all the way, the motor did stall, which is great because I know it won't just like use all its power and snap the string. But I should still add some safeguards. So in the code, I'll tune it so it can only go to the limit. But before that, let me get some good values on how many rotations it is to contract all the way and what the stall current is. Oh, I forgot to plot it. And I went in the wrong direction. I'm going to try different voltages just to see how the stator current changes. Okay, 0.25 volts is still too little. Oops, okay, that definitely reaches a stall current, but I like its speed. Over here, I made this interface to control the motors to a position. It's coded in Java in WPI Lab, and they make it very easy to have PID. So yeah, this is PID. Wow, that is very choppy. I'll figure out how to set like maybe a voltage limit, so it won't just like jump to positions basically. They're just too powerful. Okay, so now I have a little dashboard that lets you control the position of each of these motors, and yeah, it looks pretty good. The problem I'm running into is I can't control both of these at the same time, and when it like unwinds, like look at all that slack. But also here I have like this, basically like the current stator current of each motor. So like when it's like fully extended, you can see this number of spikes, and the loose motors, you know, just hovers around 0. It's pretty noisy, but there's a very big gap between these two. Okay, so with these two dials, let's try to grab an object. Researcher's paper, to be able to move objects, and you'll decrease and increase like both of them at the same time. Yeah, whatever. It's fun. Next up, I'm going to try to make the arm actually be able to carry objects. So one cable will be wrapping around the object, while the other one just going to be like maintaining tension. A huge thanks to the Iron Panthers for lending me the motors, the RoboRio, and the PDH. And thank you everyone who taught me stuff so I could make this happen. Bye.